Next, we're going to look at a hypertonic solution. So here is my beaker full of my hypertonic solution, and there's my cell. Now, hyper means more, so that means there's more solid in this solution. So now we're going to make the salt 20%. And the one inside of the cell is still 10%. So we changed the amount of water that we have out here right now. It's now 80% is what we're dealing with, compared to still the 90%. So the cell itself did not change. All right, so now let's look for that concentration gradient. So we're looking for a concentration gradient. We have one now. So inside of our cell, we have 90% water, and outside we have 80% water. So when we're talking about passive transport, we're talking about movement from high to low, just like a waterfall. So here is our high to low, and what will end up happening to our cell is that it's going to lose the water until we can reach equilibrium, and what's going to happen to the cell is it's going to shrink, and it's going to possibly not be able to make it. Now, this isn't a very extreme situation, but you could see where the little hyperactive kid might come into play, or a hyperactive adult for that matter, to where they can kind of shrink it from all the activity. But it really just looks at the numbers here of 90% to 80% moving out to that area where there's less water and causing the cell to lose water and shrink.